Thank you for joining me for this GeoConvergence workshop lightning talk today. My name is Seth Goodman. I am a data engineer at AidData. Today I'm going to give you a quick overview of how AidData's own need for geospatial data has driven the development of a tool that drastically improved our own workflows and is helping many others to incorporate geospatial data into their work. For those of you not familiar with us, AidData is a research lab at William & Mary's Global Research Institute, focused on using data and rigorous methods to improve how development investments are targeted, monitored, and evaluated. Over the past 15 years, AidData has managed more than $50 million in grants to pursue research and analysis at the cutting edge of international development with partners at leading organizations around the world. AidData has been a major advocate for the use of geospatial data in the field of development to improve how we evaluate, target, and understand aid. Today, data sources ranging from household surveys to remote sensing and connected devices produce more diverse geospatial information than has ever been available. The potential applications of geospatial data in international development are as varied as the many sources of geospatial data themselves. Environmental work leverages data on land cover and climate. You can evaluate human welfare from data sets on conflict, pollution, and population, and nighttime lights can be used to measure economic development. The importance of geospatially disaggregated data can be seen by comparing national survey estimates of child mortality with precise subnational data. Surveys with sampling designed to measure national trends can conceal critical areas where child mortality rates were far worse than national average. Identifying these kinds of hotspots can improve how aid is targeted. The incredible thing about geospatial data is that individual data sets don't exist in a vacuum. Most things you can record about our world inherently have a spatial component, which provides a common frame of reference. So we can take data on child mortality, political boundaries, climate, and more, and understand the spatial relationships between them. The potential applications that can leverage understanding those relationships are nearly endless. But working with raw geospatial data can be difficult. It requires finding and navigating many different sources, understanding spatial data formats, and having sufficient technical skills and computational resources. These barriers present challenges preventing innovation and collaboration using geospatial data in the field of international development and many others. AidData's solution to address these challenges and accelerate the use of geospatial data is to provide a simple and easy-to-use tool that would allow anyone to quickly access geospatial data for anywhere in the world. We want users with little or even no geospatial experience to be able to select boundaries for an area they're interested in, the data they want to access, and get the results in a simple spreadsheet format. To achieve this, we leverage methods that generate geospatial summary statistics of datasets at relevant units of analysis, like administrative boundaries, for the entire world. Once aggregated, data can easily be viewed in a tabular format where each row represents one unit, such as a district, and the columns contain summary values of data such as nighttime lights intensity. To make this possible, AidData designed an easy-to-use interface for selecting data that leverages the data processing power of William & Mary's high-performance computing cluster. The result is GeoQuery, a free platform designed to make getting geospatial data as easy as possible. Users can select boundaries at varying levels for every country in the world, and can immediately explore over 50 curated geospatial datasets based on relevance to the area they selected. After submitting a request, data is processed in near real time, transforming terabytes of geospatial data into easily accessible tabular data. When the request is completed, users are emailed a permanent page that was created to provide their data along with detailed data documentation. To date, GeoQuery has served nearly 25,000 data requests to thousands of users from hundreds of organizations. Tabular data from your GeoQuery request can easily be opened in any spreadsheet software such as Excel or accessed using programming languages such as Python, R, or Stata. Once loaded using referred software code, you can visualize data or analyze trends such as changes in nighttime light levels shown here. Tabular data from GeoQuery can also be joined with the geospatial boundaries provided with your request using GIS software or geospatial tools in Python or other languages. The resulting data can be used to perform spatial analyses or generate maps. The change in nighttime light levels we just saw visualized in columns can also be visualized as a map. GeoQuery is 100% free to use, public good, and is available now at geoquery.org. Keep an eye out for new datasets, features, and improvements being added over time, along with training and partnerships opportunities and related research publications. Feedback and suggestions are always welcome, so do not hesitate to contact us. On behalf of all of us at AidData, thank you for watching this GeoConvergence workshop lightning talk.